The James Webb Space Telescope, the eagerly awaited revolutionary newcomer to the pantheon of space telescopes, is finally set to make a big splash after being frequently postponed for launch, largely increasing the overall cost. Following a few holdups this year, NASA finally launched the telescope on Christmas. Both politicians and scientists were worried that the JWST project is using up resources from other areas of research. However, it's believed that the telescope will make up for its inflated cost in the overall scheme of things. The design of Webb is inspired by its predecessor, the Hubble Space Telescope, the 31-year-old observatory popular for catching stunning photographs of our galaxies. However, Webb has the potential to reach where even its ancestor has missed the mark. There's actually no telescope like Webb ever made. The new observatory was launched from northern French Guiana, close to the equator, and is a joint cooperation between the space organizations of the United States, Europe, and Canada. The Webb in space is actually the entire power of human imagination and a wide range of technologies that push it there. This most recent spacebound telescope is special due to two abilities. First of all, it's huge, with a 21.3-foot primary mirror that will make Webb the farthest-seeing telescope built by mankind. Also, Webb will be able to see the universe in the infrared zone on the electromagnetic spectrum, which is only on slightly longer wavelengths than visible light. It'll be the main infrared specialized telescope in space that can see significant distances. Its nearest challenger, Hubble, works more in the visible and has a restricted infrared viewing range. The JWST will serve a lot of purposes as far as space exploration is concerned. It will try to develop a view of how early cosmetic systems birthed and developed. One of the large motivations behind telescopes is that there's some kind of time machine in the closest sense, since distance can also be looked back in time. Researchers will utilize Webb's cameras to sort of time travel back to when the earliest systems were framing just after the Big Bang. Whenever we look at a far-off galaxy, light years away, we aren't seeing it in its latest state. Its distance in light years means the quantity of years it takes for its light to show up to Earth. For instance, the nearest cosmic system to our own is the Canis Major Dwarf Galaxy, which is 25,000 light years away, so its light requires 25,000 years to arrive at Earth. That implies when we see Canis Major Dwarf, we're seeing it as it was 25,000 years ago. The further you look into space, the further back in time they can notice the system. Webb, being the farthest seeing telescope yet, can discover the youngest universes we've ever seen. To understand the arrangement of the early universe, researchers will take a look at galaxies in various life stages and sort out their formative courses of events. Webb's infrared abilities are also vital for viewing these cosmic systems. Light from far-off galaxies gets stretched out by expansion of the universe. When the light arrives at our telescopes, its unique wavelength will have moved from the visible to ultraviolet to the infrared spectrums. Fortunately, detecting infrared radiations is definitely within Webb's capabilities. It's the first where we have an enormous, cold telescope in space that can notice these infrared wavelengths. The Hubble Space Telescope has managed to capture the shortest wavelength extended from the bluest of light of distant galaxies. The retired Spitzer infrared telescope was a lot smaller than Webb and couldn't be considered to be far into space. Webb will blow everyone's mind because of its profound visibility into outer space and how far back in time it can capture distant galaxies in the study of their development. The James Webb Telescope will also help in recognizing conceivable chemical signatures of life on different planets, subsequently permitting researchers to search for indications of something going on under the surface on such planets. If life exists beyond Earth, it should be delivering unmistakable chemical signatures, for example, by breathing carbon dioxide and photosynthesizing out of oxygen, all of which can change a planet. Investigating chemical signatures in a planet's environment won't just permit researchers to look for life, but also empower them to evaluate a planet's habitability. Furthermore, Webb can also identify infrared wavelengths of water and methane present in the environment of exoplanets, which are planets beyond our solar system. Webb contains two instruments that will permit scientists to disentangle the wavelengths of infrared signals from solar systems beyond our own. When an exoplanet photobombs a star that our telescopes are looking at, the starlight will experience a dip in certain energies relating to the chemical substances in the exoplanet's environment. Assuming Webb is taking a look at the perfect star at the ideal time, It can artificially examine the atmosphere of the star's planet by analyzing the blip in the starlight. Since the first exoplanet discovery in 1992, several others have also been observed lying in the universe. They're everywhere. However, human interpretation of these exoplanets has rarely stretched out past the knowledge that they exist. It's also challenging for current innovation, like Hubble or on-Earth infrared telescopes, to complete infrared spectroscopy on new exoplanets of interest. Hubble works with a much smaller band of infrared energies contrasted with Webb. Ground observatories are covered in Earth's environment, which itself is a safeguard and scatter of infrared light. The Earth also transmits background infrared radiation that would overpower the weak signs coming from the deep cosmos. In space, where Webb will be, Earth's environment and warm emanating surface are out of the way, providing an unhindered view of the night sky. The origin of stars are brimming with dust. While they make for amazing photographs, the residue blocks astronomers from looking directly into the core of these clouds when they try to view them with visible light. Fortunately, infrared light from stars can infiltrate enough through the residue to give scientists an entirely different interpretation of an old view. Red light can go through the residue in the Earth's environment better than the more limited wavelength, the blue lights. A similar principle makes sense of why infrared light can penetrate even further through dusty galaxies than visible light. Assuming you look at the sunset, it will in general look a lot redder than when you take a gander at it in the daytime. It's exactly the same thing. Hubble's restricted infrared capacities have scarcely started to expose what's underneath the star formation. Webb's more extensive infrared reach will empower researchers to peer further into the residue. Young stars rise up out of the dustiest pockets where it's generally difficult to see through. Because of Webb's high infrared responsiveness and spectacular resolution, researchers could possibly filter through the residue to study these baby stars in exceptional detail. Also, Webb could assist researchers with figuring out how the dust actually cooks up a star, why stars form in clusters, and how planets formed around a star. The Webb telescope will also study black holes from an alternate angle. A supermassive black hole, for example, the one at the core of the Messier 87 galaxy, is visible because of the stellar matter that surrounds it. Webb will assist researchers with noticing the stars orbiting a black hole. Nothing can escape from a black hole, not even light. So in reality, black holes are undetectable. Fortunately, twirling around black holes is a lot of stuff we can see: stars, dust, and whole galaxies. To concentrate on black holes, researchers investigate this heavenly puzzle, like concentrating on a shadow to find out about its shadow-casting object. Previously, researchers have utilized X-beam telescopes to study specific kinds of physics of black holes. These telescopes look at phenomena that are millions of degrees hot enough to deliver X-beams. Webb's infrared instruments will permit researchers to see various developments in a black hole, especially the cooler gases and stars moving around their invisible neighbor. Webb will provide valuable data to peek into the temperatures, speeds, and chemical compositions of stellar cloaks of black holes. Scientists can use this data to learn more about the mass and size of the black hole, and more about how it snacks on a star. Webb will be the first telescope of its kind in terms of its size, sensitivity, and wavelength range altogether. With its capabilities, a good chance exists that scientists will get to see something they've never seen before. This was about the recently launched James Webb Telescope and some of its astonishing discoveries that could alter forever our view of the universe. Press the like button if you like this video and tap share to share it with your fellow space enthusiasts. Also, do subscribe to our channel for more such interesting videos. Take care.